Let's find some solutions to a practice exam. So for the first problem, we want to find domain and intercepts of two functions. First, we'll look whether the function has any numerators or square roots. So for finding domain for part A, we have to impose two conditions. First, x squared minus 4 has to be bigger than or equal to 0, because this is what's under the square root. And second, x minus 3 must not be equal to 0. So we have to exclude solution of that equation. So for the first part, we get that x minus 2 times x plus 2 must be equal, bigger than or equal to 0. So that becomes, so we do a little table of signs. So zeros of x minus 2 times x plus 2 are negative 2 and positive 2. So these two factors become so negative, negative, then change the sign at 2, it becomes positive. X plus 2 is negative, change sign at negative 2 becomes positive, positive, and then the product is positive, negative, positive, and we want where it's positive, so we want these two intervals. So solution of this inequality is from negative infinity to negative 2 included, union from 2 to positive infinity. And then so domain will be this set of numbers, and we have to exclude number 3 because x equals 3 cannot be plugged in the function. It will produce 0 in the denominator. So domain is negative infinity to negative 2, union from 2 to positive infinity, and then excluded 0.3. So that's the domain for the first function. Now to find intercepts, let's find the x-intercept. So to find the x-intercept, we plug in y equals 0. So 0 equals square root of x squared minus 4 divided by x minus 3. We're solving this equation. This is an equation that has denominator. So we'll multiply by the denominator on both sides of the equation. We'll have 0 times x minus 3 equals, and then the right hand side will denominator will cancel with what we are multiplying by, so we have 0 equals square root of x squared minus 4. We square this, we get 0 equals x squared minus 4. 0 equals x minus 2 times x plus 2, and therefore x is equal to 2 or negative 2. So this is the x-intercept for this problem. For y-intercept, we plug in x equals 0 in the equation, so we get y equals square root of 0 minus 4 divided by 0 minus 3, and we see that we have a square root of a negative number, which cannot be, so y-intercept does not exist. Y-intercept does not exist. And we can see that by looking at the domain again and see that 0 does not belong to the domain of the function. So we have this is the domain, these are the x-intercept, and y-intercept does not exist. Now let's do this for the second problem. So for the domain, we must have that whatever is under the logarithm, it must be positive. So we must have 1 minus 2x must be strictly positive. And this is from log part, and we must have that x is not equal to 0 because that's the denominator. So for the domain, we'll have that 1 is bigger than 2x, so x is less than 1/2. So the domain is from negative infinity to 1/2 excluded and minus the point 0. That's the domain. For the x-intercept, we plug in y equals 0, so we get 0 equals log of 1 minus 2x divided by 0. Divided by x. Again, we have something that involves denominators. We multiply by x on both sides. 0 times x is 0 equals log of 1 minus 2x. We're solving this equation. To get rid of log, we'll raise both sides to the power. The 10 power of left hand side is 0, and 10 to the power log of 1 minus 2x. 10 and log will go away because log is log base 10. 10 to the power 0 is 1, so we have 1 equals 1 minus 2x. So 2x is equal to 1 minus 1, so x is equal to 0. So this would be the x-intercept, except 0 does not belong in the domain. But x equals 0 is not in the domain. So the x-intercept does not exist. For y-intercept, we plug in x equals 0 in the function, so I have log of 1 minus 2 times 0 divided by 0, so I have log of 1 divided by 0. So again, this does not exist.